Okay, this is lesson 4.10, page 172. You're told to do numbers 11, 13, 15, 19, and 23. I'd like to try to work through some of those with you, at least to the chart part of it, so that you can get the right equation and solve for your x. Let's start with number 11, and please pause where you want to and try to fill in things, and then unpause and see if you got the right answer and change accordingly. All right, number 11. 10 gallons of a 12% salt solution are mixed with 8 gallons of an 80% salt solution. What is the total amount of solution? How much salt is in the mixture? What is the percentage of salt in the mixture? Okay, you got 3 questions we're asking here. Let's look first. Sometimes it's easiest to reread and fill in what we are given. And so it kind of gives us a fill in the blank then, looking for other things that are not given. Let's remember first, before we do that, though, that when we have a number of gallons of a solution and we're giving the percent of whatever's in it, in this case it's salt, if we multiply the gallons of solution by the percent of salt in it, we will get the amount of salt that we have. That's our simple equation here that will help us solve for x. All right, 10 gallons of 12% salt solution. So the first thing we have are 10 gallons. Excuse me. Our 10 gallons, our first solution, we are told we have 10 gallons. We are also told it's 12% salt. So we're going to write 12% as a decimal. Now we know 12% is the same as 12 over 100, or 12 100ths, which is also the same as writing it 0.12. 12 100ths. This is the tenths, this is the hundredths. 12 100ths. Let's write that as a decimal. We also know that if we take the gallons times the percent of salt, we will get the amount of salt in the solution. Excuse me. So our first solution is already filled in. What about the second one? 10 gallons of 12% salt solution are mixed with 8 gallons of 80% salt solution. So we know we have 8 gallons of another solution. And we know that it's 80% salt. I have to give some water, I'm sorry. We can write it as 80 or just 8 and drop that 0. And again, we can multiply across. If we multiply across, we can fill that in. I'm going to grab some water. 8 times 8 is 64. And you just put your decimal in. 6.4. All right, now let's look at the mixture. So we know that the mixture is combining these two solutions. And we know we have 10 gallons in this solution and 8 in this one. That would mean that the mixture is going to make 18 gallons. That's kind of an easy one to fill in. Now, we don't know what percent is in that 8 gallons. You can't just add these, because 10 gallons of it has 0.12% of salt, or 12% of salt, and 8 gallons has 8%. There's not an even amount of each. You can't just add these and say you have that. So we don't know what the percent of salt is in this mixture. That is our variable. Now we can represent the amount of salt. We don't know what it is. We can represent that by doing exactly what we did here and here, multiplying, getting the answer. When we multiply, we get simply 18x. Now we can write an equation from the information we have from our chart. If we look here at the amount of salt, we know that this amount of salt in this mixture is 1.2. We got 1.2 amount of salt here and 6.4 here. That is the amount of salt we have. It's not a percent of this or this. It's the amount that each one of them has. And we know that 18x is the amount that we will have in our mixture. Well, if we add these two together, it should get what amount we have in our mixture. So our equations should represent that. If we take 1.2 from our first mixture of amount of salt and add the second amount of salt, it should equal what our total amount of salt is in the mixture. So that would be your equation. And I'm going to let you solve that. If you get stuck, you can ask your parents to look in the answer key to help you, but that should be a pretty simple solution to x. Once you solve it, though, remember, your questions were, what is the total amount of solution? So you should write 18 gallons. We already have that answer. How much salt is in the mixture? Well, once you solve for x, you will get a percent of salt in the mixture and amount of salt. The how much salt is in the mixture is this one, amount of salt. So you will have to solve for x, and then it would be multiplied by 18 to get the amount of salt. And once you solve for x, you can also figure out what the percent of salt is. That is just simply x. And that's your last question here. All right, you go ahead and finish that one. I'm going to move on to this one. You can pause and finish this and then come back to me too. All right, 13. Dilute 35 gallons of 40% acid with 7 gallons of water. What is the amount and strength of the mixture? All right, we have two different solutions again. We have an acid that's 40% acid, and we have water, which isn't going to have any acid in it. It's just pure water. So let's start with our acid. They tell us that we need to dilute 35 gallons of acid. So we know we have 35 gallons. We're going to be diluting that 35 gallons, but we do have 35 gallons of acid, and it's at 40% of it is acid, so it's quite high. And if we multiply these together, like we did before, we know the amount of acid in that first solution would be 14 gallons. Okay? Now the water. It says we have 7 gallons of water, so we can write that in. What is the percent of acid in the water? Well, it's pure water, so it should have 0% acid, which would make sense that the amount of acid in it then would be 7 times 0, which is 0. All right. So what is the amount of the mixture? That one again is easy. If we take 35 gallons of this solution and 7 of this, you just simply add it up. That's how many gallons of mixture you will have. And again, in this one, we are solving for how much acid is the mixture. Now you see this. This is a good example of how you can't just add down on these. If we added 0.4 and 0, we'd have 0.4. That doesn't make sense, does it? Because if you have a 0.4 acidity of acid in this one, and you dilute it down to 7 more gallons of just water, it's not going to end with the same percent of acid. So that's what we're solving for. We're solving for x. We don't know what that is. We have 35 gallons of this and only 7 of this. But here, this amount of acid and this amount of acid will still equal the same amount of acid here, right? Well, we're going to represent that as 42 gallons times x, because the total amount of gallons times whatever was the percent of acid will be the amount of acid in this. And then, like we did before, we can say, well, the 14 gallons of acid here and the 0 gallons of acid here will still be that same amount of gallons. But we want to solve that with our 42x to get what is the percent, okay? So this plus this is this, but we have to solve for x to know what this is and this. So your equation would be 14 plus 0 equals 42x. And you go ahead and solve that, and then make sure you answer what is the amount and strength. The amount will be here, and the strength after you solve for x. Okay, go ahead and pause, and I'll go on to the next one. Okay, 15. Mr. Harper, the candy store manager, wants to mix butterscotch candies and cinnamon balls to make a deluxe mix to sell for $3 a pound. Butterscotch sells for $3.40 a pound, while cinnamon balls sell for $2.90 a pound. How many pounds of each should be used to make 20 pounds of the mix? Sounds pretty complicated. But really, it's similar to the mixture problems, only in candy form. We're mixing two types of candy. We're going to use the price per pound to help us, though. We know that if we have 1 pound of candy and it costs $3 per pound, 1 times $3 is going to be a total price of $3. Or 2 pounds of candy at $4 a pound is 2 times 4 is going to be $8. This is the equation we're going to use to solve this problem. Let's fill in what we know about the butterscotch, the cinnamon balls, and the mixture. Okay, let's read through again slowly. Mr. Harper, the candy store manager, wants to mix butterscotch candies and cinnamon balls to make a deluxe mix to sell for $3 a pound. Okay, so we know our mixture is the deluxe mix, and he wants it to be $3 a pound. So we can fill in when we know the price per pound he wants it to be. Now, butterscotch sells for $3.40 a pound. So here's our butterscotch. We know it sells for $3.40 a pound. While cinnamon balls sell for $2.90 a pound. Our cinnamon balls sell for $2.90 a pound. The question is, how many pounds of each should he use to make 20 pounds of the mix? So he wants to make 20 pounds of the mix. Question is, how much of each should he use then to make 20 pounds of the mix? Well, I see here we can finish this column because we have two of the answers. 20 pounds times $3 a pound means this is going to cost a total of $60. Well, we can't do that here because we only have one answer here across butterscotch and cinnamon balls. But we can do something here. Think about that for a moment and try to figure it out yourself. Maybe pause. We have 20 in all. So we know that this and this is equal to 20. Just like we said 35 gallons and 7 gallons was equal to 42. Well, we don't have what the amounts are here, but we know that both of them are equal to this. So if we just say butterscotch is X, we don't know what it is, then the cinnamon balls should be 20 minus the X, shouldn't they? For instance, if we have 5 pounds of butterscotch, then 20 minus 5, there should be 15 cinnamon balls. So that's how we can represent that. Even though we don't know the individual ones, we can represent what they are with the X variable. Now we can multiply across as well. The total price will be $3.40 times X, or 3.4X. We can write it at drop the 0. And then this one you have to be careful with. We have 20 minus X times 290. The reason why you need to be careful is you need to make sure that that 20 minus X is one whole number times the 2.9 or 290. You can't just multiply the 2.9 times the X or the 2.9 times the 20. It has to be the whole as a unit. This has to be a whole unit. So you have to distribute that, right? 2.9 is times the 20 and times the X, the negative X. Now think about this for a moment. Now we have all of these. And think about what we did before. We can add these down, right? If this is the total price of the butterscotch, and this is the total price of the cinnamon balls, together it should equal the total price of the mixture. So if you add these two, it should equal this, correct? Because this is the price and this is the price. It needs to equal this total. So that would be your equation. 3.4x plus parentheses 20 minus x times 2.9 will equal your 60. Now be careful as you solve this one. Remember, this has got to be distributed here and here. Start with your parentheses first and distribute that 2.9 before you go on. And you go ahead and solve that and make sure you answer the questions up here well. Also remember to always have a problem A word problem should have a number and a word to label it at the end. Make sure you have that on all of them. All right, let's move on to 19. In 19, how many gallons of pure water must be added to 10 gallons of 30% salt water to make a solution that is 25% salt water? All right, let's fill in. This one's fairly simple. Let's fill in what we know, and then we'll go from there. Gallons of salt water. How many gallons for pure water must be added to 10 gallons of 30% salt water? So we have 10 gallons of 30% salt water, and it needs to make a solution that is 25% salt water. So this is the solution we're going to make, the mixture we're making, and they want it to be 25% or 0.25 of salt water. I mean of salt, percent salt. Okay, but we can also fill in the water, can't we? The water is what we want to know how much to add. How much water are we adding to the salt water in order to get this percent of mixture? We're diluting it by 5%. So we don't know how much that's going to be. So that would jump out at you as your variable. What is the percent of salt in our water? Well, we know that that's 0. It's pure water. There should be no salt. And if we multiply this across, x times 0, it would mean that there is no salt in the water. The amount of salt makes sense. You can also fill this one in. 10 times 0.3% of salt would be just simply 3 gallons of salt. So out of the 10 gallons, 3 gallons are salt. Out of the x gallons, 0 gallons are salt. Now the mixture. Well, the amount of mixture here will be this and this combined, right? Whatever gallons of each of these combined. So we can write this mixture. We don't know what it is, but we do know it's 10 plus whatever x ends up being for the water. That will be our total gallons of the mixture. And now, likewise, we can multiply these across, right? Again, you're going to have to make sure you keep that 10 plus x as a unit. 10 plus x. So that when you multiply it by 25.25, you're not just multiplying by just the x or just the 10, but it distributes to both of them. So, similar again, think about it. Think it through. The amount of salt in this one, and we're adding the amount of salt in this one, should equal the amount of salt in this one. Okay, so this equation should equal this amount. And if we solve for x, we can figure out where our blanks are. So 3 plus 0 should equal the total amount of salt here. And you need two different equations in order to solve for x, right? You can't just write the same numbers. So now you should be able to solve that equation. Of course, you're like the other one above. You can start by dropping that 0 right away. And then distribute would be your first thing here. Get rid of the parentheses by distributing your 2.25. Go ahead and solve for x and then fill it in. X is going to be your gallons of water, but it also is going to help you figure out how much of your mixture how many gallons of mixture you had, and it's going to figure out for you the amount of salt you need or you have in your mixture. All right, last one. Stick with me. All right, a nurse wants 4 liters of 5% iodine solution. She already has 3 liters of 3% iodine solution. What percentage of iodine should the additional liter contain? All right. She wants 4 liters. So that's what the end product or the mixture is, right? 4 liters. And she wants it to be 5% iodine. Careful writing that percent. Don't just write 5. It needs to be 0.5, right? Because it's over 100. 5 over 100 would be 5 hundredths, not 5 tenths. And then we will also know the end product of that, right? What is the amount of iodine in that? If you multiply 4 times 0.05, you should come up with 0.2. All right, what do we know about the two solutions? Okay, we wanted 4%, 5%, 4 liters of 5% iodine solution. She already has